We got another problem on mathematical induction for this video. The first couple were pretty straightforward. The third one got a little bit more involved. And this one, I guess, goes to the next level, but pretty close to the third one. It says use the principle of mathematical induction to prove that the given statement is true for all natural numbers n. So we want to prove that the product of three consecutive natural numbers is divisible by 6. They have n, and then one more than that, and then we got n plus 2, one more than n plus 1, so we have three consecutive integers. We want to prove that this product is divisible by 6. So let's go through the steps. Just to make it easier on me, I printed this out, or typed it out I should say. So step 1, we have to show that the statement is true for n equal 1. So for n equal 1, just plug it in there. So it's 1 times, then 1 and 1 is 2, times, and 1 and 2 is 3. 1 times 2 times 3 does equal 6. And 6 is divisible by 6. So this one is done. That's all you have to do for the first one. Now you can double check and try n equal 3, n equal 4, and so on. But you don't have to for this particular theorem. So step 1 is done. And then for step 2, you assume that the statement is true for n equal k. And then you show that if that's the case, then it's going to be also true for n equal k plus 1. So here's n equal k. And all it is the same statement, the n replaced by k. So k, and then the next one, k plus 1, and then the next one after that, add 1 to that, k plus 2. Again, three consecutive natural numbers. And then you multiply these out, because this is going to help you show that the statement is also true for k plus 1. In other words, if it's true for k, it'll be true for k plus 1, and that pretty much proves the statement. So it helps though if you multiply this out. So k times k plus 1 times k plus 2, just the basic algebra. And you have k to the third plus 3k squared plus 2k is divisible by 6. So this is assumed. It's a statement that you assume. So when you see this here and further work, you're going to know it's divisible by 6. So now what we want to do, we assumed it's true for n equal k. Now we have to prove or show that it's true for n equal k plus 1. So notice here, instead of starting with n or k, you start off with k plus 1, because we're starting off the next one after k is k plus 1. So k plus 1, and then one more than that is k plus 2, and one more than that is k plus 3. And then the rest of it is just algebra. So I multiply k plus 1 times k plus 2, get a trinomial, and then multiply that by k plus 3, and I get this result right here, which is the same as this right here. Now what I did here, I broke it up. So notice here I have a k to the third here and k to the third here. I have a 6k squared here, and I broke that up. I broke it up. The 6k squared went right here, 3k squared and 3k squared right there. And then the 11k, I broke that up also. I took 2k from it. There it is right there. And what's left over? 9k. So what I have right here, and then of course you got the 6 from right there. So what I have right here is exactly what I have here. Just broke it up. And why did I do that? Because this right here, k to the third, 3k squared, 2k from right here, that's the assumption that the statement is divisible by 6. The given statement is divisible by 6. So I know that the k to the third, 3k squared plus 2k, this right here, in that parenthesis, that expression or that number, or whatever that number is divisible by 6. It's just divisible by 6. And then here I factored out the 3 from the last 3 terms here. Factor out a 3 here. And then that left me with k squared plus 3k, and let's factor that. So the k squared here, 3k plus 2, that's going to factor into k plus 1 and k plus 2. k plus 1 times k plus 2 are the factors of this trinomial right here. And what do I know about these? What do I know about k plus 1 and k plus 2? K plus 1, and then I add 1 to that. So they are consecutive. These two here are consecutive natural numbers. Now think about it. If they're consecutive, for example, 1, 2, or 3, 4, or 5, 6. If I multiply any two consecutive natural numbers, one has to be even. Think about it. 1 and 2, 3 and 4, 5 and 6. So one of these is even. What do I know about an even natural number? Any even natural number has a factor of 2. Has to, right? 4, 2 times 2. 6, 2 times 3. So when I multiply these out, that's going to be even. So I know that's going to have a factor of 2. But then look what I have in front. I have a 3. So this product right here is going to be divisible by 6. So from that we conclude this expression is divisible by 6. That's the assumption we made, okay, in the proof here. This is divisible by 6, and based on what I just said, this product here is divisible by 6. So this one's divisible by 6, this one's divisible by 6, so the sum will be divisible by 6. And that tells me then that for n equal k plus 1, the statement is true. I just showed, just doing this, I showed that if I replace or go from k to k plus 1, that expression will also be divisible by 6. So we can conclude that the statement is true for all natural numbers. Thanks for watching. We'll see you next time.